Thank you so much, Chairperson. I would make this presentation like DG said. It would have been good if we were going to show on projector, because there are some pictures and some maps that we wanted the committee to follow as we make this presentation. But nevertheless, Chair, the way we have structured our presentation, we were guided by the letter that we received from your committee, Chair, in terms of issues that we wanted us to present. So our presentation is basically answering to that and few and add more issues that were obviously not part of the petition, but we felt that if the committee is going to be traveling to Hwange, it will not be in order for you to begin to hear certain things when you are now there, and EMA would not have briefed you on those issues. So I would indicate those new issues that we have added as we make this presentation. So yes, we acknowledge the petition that you referred to by Mr. F. Chima, representing Greater Hwange Residents Trust. We appreciate so much when these things are being brought forward by communities, because that's the only way you can protect the environment. This is the reason why you see we say that we protect the environment together with stakeholders. It's not an EMA business alone. So when residents and general citizens are bringing environmental issues to the fore, particularly to the extent of bringing things to Parliament, to us it's a class, because we have a department, Honorable Chair, that deals with environmental education and publicity, and this is exactly the issues that we will be educating our communities on. That you must not be silent, you must be able to speak out and defend. You are the first line of defense when it comes to environmental protection. So in terms of our presentation, we are going to talk about the source. Where is the problem? Identifying the source, the background, and the historical context of the environmental challenges that we are talking about. And it would also good, Chair, that we talk about the magnitude. To try and explain to this committee whether the issue really is of that magnitude that requires your committee's attention. We are also going to be speaking about possibly how do we rehabilitate, how do we make good, and the enforcement mechanics that we have been employing, what has worked and what has not worked, and what is it that we are asking the committee to do, which the Director General has already outlined, one of which, obviously, Chair, is to strengthen the legal framework. So that's how this presentation is structured, Chair. It's true, Chair, that we have Deka River in Martinov, Hwange area, which stretches for about 139 kilometers and support quite significant rural economy as it transcends through communities down to the Zambezi Valley, where it ends into Zambezi. And obviously by that it then becomes international waters from that point. And it's a very important river to protect that transboundary nature, because we have certain protocol, shared water courses and so on, and you want to be a good neighbor. So making sure that we deal with our pollution before it gets into international waters, Chair, becomes very, very critical. We want to, at the outset, Chair, to present to you where the root of the problem in terms of historical context. You would recall, Chair, that mining in Hwange started around the 1900s. In 1901, a colliery company begins mining near number 1 village, In the 1960s, underground mining in the affected area ceases, works are abandoned. So we have areas that were mined and abandoned as late as the 1960s. And it has always been our issue, Chair, speaking about decommissioning and decommissioned mines in this country. To say, you can't say I have mined and it's done, because environmental issues have a tendency to resurface well after mining has happened. So that's the case. In the 1990s, the problems becomes visible. In fact, in the 1960s, water accumulates in the abandoned workings and reacts with sulfide-bearing rocks, becoming what we are going to constantly refer as acid mine drainage. The water which is coming out of the underground workings that were ceased to operate around the 1960s. So in the 1990s, the problems becomes visible as the acidic water migrates through the geological faults and old exploration bores. So when you go to Hwange, Chairperson, as you approach the railway crossing, you do see the water that is flowing from the upside of the road flowing downstream. I think it's a perennial feature. You can't miss it when you are going to Victoria Falls. That's the water that we are referring to say that water is acidic. When we say it's acidic, that means its pH is around, usually when we monitor, around 2, in some instances rising up to 4, but it's generally revolves around that range. What it means is that it's you can't use that water for anything else because of that acidity before you treat it. So today, Chairperson, Hwange Colliery has plugged some bores and built passive wetland treatment, but the acidic metal-rich signature remains detectable, particularly in the dry season. So it continues to flow even during the dry season, that water that you see. And most importantly, what I have to point out, Chairperson, is that naturally Deka River, where it starts when you have gone, you see you cross the railway line, and then you cross the bigger bridge. That's Deka for you. And if you look into that river, it's dry during the dry season. But on this side, we call it, those streams, we call it Runduwe and Skaba. It comes from ZPC, Hwange, and those acid affected areas. So that's the water that you see. So the Deka way it starts, it's not all year round. It dries up July up to October before the rains. There will no flow there. So the flow that you see on this other side is this water that we are talking about. So we had asked a question in our PowerPoint to say what is actually coming out of the ground. So think of the old underground workings as a flooded basement. Rainwater and groundwater fill the abandoned channels and react with the naturally occurring sulfide minerals in the coal seam. The same chemistry that turns exposed pyrites, we call it fool's gold rust. The result is water that is acidic and carries dissolved iron, manganese, and that water find the path least resistance, old bore rocks, fractures, and surface at a single precisely identified point. So when you go there, you see various points which looks like aquifers, shooting out of the ground. So all that water that is coming out will be acidic. But the major problem is that how do you account for quantities? Who knows how much quantities at each given season or time that are accumulating underground? That makes it very difficult, even worse, to deal with it, because you are not in control of the quantities, how much is being generated at a particular time, and so on. But yes, EMA, we have a point, Honorable Chair, that if we have an opportunity to accompany your committee as you go to Hwange, we are able to identify and show you the points where we are doing sampling of that water and take it to our laboratory for analysis, just to check on the quality, whether it's changing, whether it's improving. We have those points, and we actually have data that dates back to as far back as 5 years to show you the trends of that water. And we've given those points indicator names. We call it MTN20. So on your PowerPoint you can see where it's written MTN28, where it is written EMA has traced this to one location. So the historical Hwange acid mine drainage discharge point and the principal persistent source affecting the defined Deka River impact region identified across 5 years of monitoring. So there are photos to that. When you go to the next PowerPoint presentation, where there are a collage of pictures which has got a Google map at the center, I wanted to juxtapose the pictures on the map to show you that this picture was taken here, this picture was taken there. So the picture on your top left corner chair, which has got significant amount of water and those dried trees up there. When you are going to Hwange, it will be on your left before you cross the railway line. So that photo was taken on the left side. So if you go during the particularly dry season or just at the end of the your rain season, the water will be quite significant, but it will be also have accumulated underground. So it will be coming out with much pressure. But when it's during the dry season, well, it will be draining here and there, but it continues to flow. And on the down picture on the left side where there is that signage, Hwange Colliery Company is trying to show that they are at least doing something by damming that water. So it accumulates. There's actually a dam of this acid water. They just thought it can be left draining down. So they've created a way there where that water accumulates. It accumulates there. They try to dilute it or are using lime, but obviously we will talk about the effectiveness of their intervention later. And that Google map shows you the Skabala and Unduwe streams which are carrying this acid water into the main Deka, which is that deep blue stream that you see on the left side of your Google map. The next, members, if you are following on your phones the presentation, there are ponds there that are written temporal acid mine drainage holding ponds for treatment by Hwange Colliery Company. And you can just see how much those ponds in terms of size. They are big when you go on the ground, and obviously retention time is very important. They then eventually release that acid water down the stream into Deka River. We have a PowerPoint, a slide that we have shown to say how EMA reads the evidence, source, pathway, and receptor. So we have already talked about our source. Our major source, obviously, is the Hwange old workings. They have ceased to mine that particular area. In terms of mining, we can say it's now an abandoned mine at that particular place. Which is then accumulating the acid mine drainage that we have talked to, which is the MTN28 that I've spoken to. And we are now looking at two streams of different quality of effluent. So we have another stream of, we call it effluent, water that is gone through a process. So we have water that is coming from ZPC1. You usually see that water when you cross the railway line, right? There's a smaller bridge that you cross before you go to the bigger bridge. You see that water is always flowing. That water is also coming from ZPC1. ZPC Hwange would have used that water for their cooling system and processes, and also discharges it into that stream. which is Runduwe stream. We also monitor that. That effluent from ZPC now is very alkaline, because it's a highly alkaline, meaning it's directly an opposite of what we have been discussing. This one is acidic, that one is alkaline. So when the two tributaries meet near the PC tributary and upstream Deka water dilute, buffer oxidizes and settle out the acid mine drainage influence. So when the two meets, the one with acidic and the one with a bit on the high end in terms of alkaline, they try to dilute each other, which is what we are trying to do. When you see the treatment process, as we explained for Hwange, they are trying to neutralize the acid water, which is what exactly the water from ZPC is doing to this one, which is acidic. But the challenge is that nobody is controlling the mixing ratio, because this is just happening naturally. This water flows from there, this one flows from there, and they just meet. And when they meet, they then try to neutralize each other. But what then happens is that it's not only acidity that we see, it also then carries other heavy metals, this effluent particularly that comes from the acid mine drainage. It also have iron elevated, it also have manganese out of spec in terms of what is required in the naturally occurring water streams. So when the two then meet, you then the receptors then becomes our environment. There is aquatic life in the water streams. Livestock is also, partaking that water. We also have communities and downstream environmental functions, which we will continue to explain as we go. So I'm sure, Chair and committee members, you have seen at one time there's a video that continuously circulates for Hwange. It started circulating around 29 June 2022, where they show you very deep blue water. And when you see it on video, it looks quite bad. So we've tried also to investigate what is happening in terms of that. So that location where that video is being taken, it's after the confluence of the effluent that comes from ZPC and this one, which is acidic. They mix it together. The dilution tries to happen. There are so many chemical reactions that then happens, to the extent that when you visit, Chair, you shall then see that the sediments on the floor of the river as it joins Deka now, there will be yellowish, whitish sand that you see very clear. But if you sample that water out of the river system, that deep blue color disappears. We have what we call a depth samplers. They are transparent. The long is longish. If you are following on your PowerPoint, Chair, that's what that arrow with a red arrow pointing to that jar there. It's that one. It's when you take out that water from that river, it then becomes very clear. It doesn't show you that deep blue color that is being reflected while it's in the river stream. We have investigated to say what could it be, what it is, and we have noted that because of the reaction that is happening between the alkaline effluent and the acidic effluent, reactions happens. Then the reflection of the light as those reactions are happening, natural light, it then brings in that color that you see there. Scientifically, it is proven elsewhere. So we also find out, discovered the same. So the turquoise blue coloration is therefore mainly attributed to the interaction of colloidal materials in the water with light, resulting in light scattering. This is typical of most of the water containing high levels of calcium and sulfate ions in equilibrium with their salt in solid phase. So this was confirmed when the turquoise bleak concentration was not visible in the water when samples were collected in transparent containers and was colorless at reflection to the eye. Though not toxic, I think this is where everybody else is waiting for to say, yes, it is that deep blue color, so what is the impact? What is the meaning in terms of the ecological health of Deka River? So though not toxic to aquatic flora and fauna, the deposition of precipitates in the riverbed and the changes in color may potentially affect the suitability of the river as a habitat for aquatic organisms and the photosynthetic processes of the ecosystems respectively. Further, the discoloration reduces the aesthetic value of the water body. This is the reason why people are worried and people are questioning to say, but what is this, and so on. So we thought we would explain that this is where it is coming from. We have also spoken to the enforcement efforts, Chair, that we have been doing. We have been doing quite a lot every other time, applying the fines and penalties that are obtaining in terms of the current law, but obviously we have noted that it's not deterrent, Chairperson, to be honest, in terms of companies that are polluting. They are also in business. I'm sure a penalty should make meaning to their bottom line in terms of business, so that they are also serious about controlling pollution at source. We have given tickets, we have given what we call environmental protection orders, but out of all the enforcement efforts that we were doing, we have noted that 75.6% of that effort goes towards issues of water pollution, confirming that water pollution is our real problem. Like I indicated, the major handicap there is the level of fines and so on, which we are then trying to address, Chairperson, through the EMA Amendment Bill, which is going to come before you. We have tried to make sure that it makes sense in as far as making sure that people become accountable is concerned. We've also tried in the next slide to break down our enforcement efforts in terms of tickets and environmental protection orders, and showing companies that were prosecuted. It shows that Hwange company was prosecuted, Coalbrick group of companies, ZPC, Hwange Power Station, Sunrise Chilota, Zim Jojin Electrical, and other operators. So we've been trying to, as we do our operations, we do operations, Chairperson, on quarterly basis, inspections and audits. So we don't lose information. It's actually continuous. We can track quarter by quarter to say, last quarter, this company was penalized for this, and then the next quarter, if they improved or not. So the prosecution, inspection and environmental auditing mechanism is happening quite frequently. This is the reason why we are able to give you statistics that we are giving you, Chairperson and the committee members. The next slide, we tried again to elaborate on how EMA determined the extent of the pollution. EMA did not rely on single snapshot. 3 complementary lines of evidence gathered over 5 years, Chairperson, were triangulated to answer exactly what the committee asked us in terms of the letter that we received. We have what we call routine ambient monitoring, which started in that area around 2021 to 2025. So we have 5 years of monthly sampling at defined points, allowing the catchment establishment the long-term chemical pattern. So we are able to share with the committee in terms of the results that we have been finding for the past 5 years. And we are also able to go on the ground and indicate to the committee areas where we are sampling and why we are sampling in those particular areas. We are also have the capacity, Chairperson, when you visit with your team, to demonstrate on-site testing. We have field equipment that we can have results of that water on site there and there. Of course, we then complement with our laboratory, which is ISO 17025 certified. It's quite a competent lab. It's recognized in the region and beyond. We have received samples from far afield, from other countries for proficiency testing and so on. So we believe that we have quite a capacity, good enough to give you, accredited results when it comes to the water sampling. So we, in June 2026, this year, Chair, we do a dedicated river length survey established precisely how far downstream the impact extends. So we wanted to check, because when people talk about Deka River, there is tendency to generalize, to say Deka River is polluted. And one thing that is the whole stretch, 139 kilometers of Deka River, which is polluted. I'm going to be speaking to that question, Honorable Chair, as I continue to present. And we also do what we call biomonitoring survey. Biomonitoring survey, basically, Chair, we are using aquatic life at each point. We go into the river and assess the aquatic small, what do you call them? Microvertebrates. Whatever you see living in that particular water moving, we assess that, because they indicate different issues, because they have different pollution tolerance levels. So when we see a particular microinvertebrate, we are able to then say this water is polluted, or this water is polluted to this extent, or it is not polluted. For example, when you see Muramba in any particular water body, the conclusion will be that that water body is polluted, because that type of a fish is able to live under very strenuous conditions in terms of pollution. So we've been triangulating all this, what we are presenting, to make sure that we present facts before this committee. The next slide talks about the 5-year journey, which we have termed one consistent pattern. So we have upstream Deka. When we go on the ground, we will show you where Deka starts, which is our MTN 34. So we also do monitoring there. Why do we do monitoring? Because we want to see where pollution is starting and what impact is it bringing, and also to be able to apportion, to say this pollution load that we are now seeing is coming from this particular company or is coming from this particular source. So MTN 34, Chairperson, is generally within limits. The river's natural baseline condition is good. So we have ZPC tributary. We monitor it using a point that we call MTN 18. It's near neutral, confirmed not to be a source of the persistent acidity, because our laboratory results are showing that the water that is coming from ZPC is almost alkaline. But when we come to MTN 28, we have put a red bullet there. A red bullet on your presentation shows that it's in the red class. When we talk the environmental language, we say it's in the red class. So because of the acidity that we have talked about. So we have a point that we call a WK, which is a combined tributary of that which comes from ZPC and that which comes from the acid affected area from the old workings of Hwange. pH and iron mostly recover, manganese remain frequently high. pH recovers because of the dilution effect from the Hwange effluent. It now dilutes this one which is coming from the acid mine. But now we have a problem of heavy metals. We have iron, we have manganese. We also have a point, Chairperson, post-confluence Deka, when the two streams meet with the Deka River now. After that, we have a point which we call MTN 21. That MTN 21, pH and ion recover well. we realize that iron and pH continue to come within the limits, but our problem now, manganese still will be lingering on the high side. So consistent 5-year interpretation, the river recovers through dilution, buffering, and precipitation, but manganese remains the most persistent downstream signal of the unresolved acid mine. The next slide, Chair, where you have those Google Maps with river indication, which is written June 2026. How far downstream does it reach? I think this is the most critical question. The committee would want to know, is it the whole 139 river course affected, or is it a particular stretch? So we have tried to elaborate all what we have been speaking to. So we have put results of what we are getting at each and every particular point, MTN 34, what we have been talking about. But in summary, Chair, the detectable dry season impact is localized to approximately 10 kilometers or less. So the entire 139 Deka is not uniformly polluted. The impact occurs within a defined reach with a clear progressive recovery downstream. So we do this sampling, particularly the last that we have done. We have done it to a point which is called Samangani. I think it will be, that point it will be 10 to 15 kilometers before the Deka River ends into Zambezi River. And it shows that the river would have recovered all the way. Our dangerous zone is the 10 kilometer stretch of the river. So that's where we have issues to talk about. The next slide, I think we have already discussed about this. Water chemistry is only one line of evidence. EMA also studies microinvertebrates, the small insect larvae, snails, aquatic worms, and that live in the riverbed, because different species tolerate pollution differently. Their presence, diversity, and abundance act as a living long-term record of water quality that chemistry alone cannot provide. So we just presenting this information to the committee so that we allay fears that possibly you are not, there is something that you are missing. The whole river could be affected. So besides taking samples for chemistry testing at the laboratory, we are doing this biomonitoring to confirm as well. So the next slide, Chair, speaks about rehabilitation plans and accountability. Every active mining project is legally required to hold an environmental impact assessment certificate and to operate in line with the approved environmental management plan, rehabilitation plan, and decommissioning plan as well. Operators remains responsible by law for progressive rehabilitation, license compliance, and managing residual risk as long as they hold that particular license. So, but where is the gap, the accountability gap, and that the committee should be aware of? A recurring gap arises where production is effectively stopped, but the operator is not formally declared a decommissioning, often because it is still seeking investment to resume operations until that declaration is made. Final closure and rehabilitation obligations are not legally triggered at that point, even though the site behaves in a practice like a closed one. The point that we are trying to make, Chairperson, is that mining goes through cycles. We have a peak cycle. We have a cycle where maybe because of let's, for example, a dip in price of that particular commodity on the global market, mining can slow down. We have those examples. From an environmental perspective, we are at times limited to declare a complete rehabilitation, because there will be an argument to say, but we are still mining. It's only that we have gone through a phase, but we are still mining. So it is at that particular point with some of these things then begins to degenerate. I know, for example, one of the companies that is downstream of this acid mine drainage that we are talking about, they at one point were not working. You go there is runoff coming from the coal that they've mined, polluting the river as well. But they would tell you that we are not decommissioned. We are coming back, we are just seeking for investment and so on. Those are some of the areas that we think, in terms of legislation, they need to be looked at. For example, Hwange Colliery is historical underground workings predate the current EIA EMP licensing regime. Its ongoing acid mine drainage liability is being managed voluntarily, lime dosing, wetland treatment, bore plugging, rather than through an enforceable funded closure plan, which is precisely the gap where Parliament's intervention can come through. Because the workings of Hwange that we are talking about, 1960s, the Environmental Management Act came 17 March 2003. And obviously you don't apply the law in retrospect in some instances. But we are saying we have a problem at the end. This is the reason why in Director General's remarks, he said possibly there is need for us to declare this situation an environmental or ecological disaster, so that new thinking can come up, new ideas, strategic thinking around financing. How are we going to do it? Because we can't just as a country let it go, because it's an issue for the people who are living downstream. So in terms of what is working and what still needs to be done in terms of the acid mine drainage that we are talking about, whilst Hwange Colliery realizes that it is their baby, but reality on the ground seem to indicate that this thing is now beyond their capacity in terms of attending to it. The problem of acidity in terms of water is that even if you sink much money to treat it, there is little that you can recover out of it. Even if you want to treat it for other uses, but the cost of treating just 1,000 liters of water for you to make commercial sense out of it, it does not match. It's high and it's complex. So they are dosing with lime, but obviously those issues to say ratios, how much are they dosing and so on, becomes a problem. They are also, that water goes through a wetland and so on. But all those things, we believe is just temporal and insignificant in as far as the problem at the end is concerned. Bore plugging, plugging those areas where it looks like aquifers, they go there, try to physically, mechanically block it and so on. But it just find another weak point and shoots from another point. So it's continuous plugging and replugging. So we believe that again is not working. EMA enforcement is stop the illegal discharges and addresses pollution risk from other operators. Our enforcement efforts are working, but they are working in other areas where these are the companies that are active, including Hwange in other areas. But it is not working on this particular one. Even if we give them an order to say, rehabilitate, stop the acid mine drainage. But remember, we don't have control of how much that acid mine is generating underground. The quantities are not known. You can't have a massive treatment of that acid water, which is coming out because, again, of course, constraints. I think Hwange Colliery was recently under corporate rescue and all these other things. They are also financially going through a bad page. So for them to then quite heavily invest in this particular problem, again, it's an issue. We are also just working with other partners, National University of Science and Technology, just for research to try and see how much of a problem are we sitting on and so on. But the end game is that we obviously need quite a significant amount of capital outlay to be able to be dealing with this. You would realize, Chair, that in the petition that we saw, the petitioner also raised an issue of air pollution, though it was not really given emphasis, but it was talked to. So when you go to Hwange, we've done some work around there. In water, we call it ambient water monitoring. In air, we also call it ambient air monitoring. So there are some work that we have done there in terms of ambient monitoring. And we've realized that yes, there is quite an issue when it comes to what we call PM10. PM10 just referred to, these are particle sizes. Generally, you may call it dust, which we find in the ambient air of Hwange. The limit of that should be, we are using the Standards Association of Zimbabwe guideline, which says it must not be 50 micrograms per cubic meter. But you see that all the results that we're getting were far beyond that, meaning that there's a lot that needs to be done in terms of air management, air quality management in Hwange, particularly hauling roads. All the roads are not tarred. People are transporting a dusty mineral, which is coal. The roads are dust. I'm sure you will see when you go there. So there's so much that needs to be done in terms of the road network and everything. In terms of the point sources, I think Hwange 7 and 8 is a good example. We are going to see they've done a good investment in terms of bringing in pollution abatement technologies that are available nowadays, as opposed to the old ZPC that you see. So we believe that technology is available, and companies, we are forcing them to invest in those technologies. And as EMA, we are also in the process of enforcing what we call continuous emissions monitoring. That should be able us to monitor emissions across the country at central point, because they can just put the sensors at their air emitting points, and we will be monitoring from the office. Once it exceeds, it pops up, we'll then be able to enforce. But the major challenge in Hwange is the issue of the roads, which are dusty, they are not paved, and all that. So the other issue, Chairperson, that was not indicated in the petition that we thought we want to inform the committee is about what we are calling Hwange coal seam and waste fires. So there is fire that naturally is occurring underground of the areas that they have worked because of coal. Once it, because of the sulfides, once it gets moisture and oxygen, it begins to burn. This is the reason why you go to Hwange, you always see smoke smoldering, almost quite a number of places. It's because of the spontaneous burning of coal that would then happen. But of late, when we attended to it, we had received the reports from, again, stakeholders, and the colliery company also confirmed the issue. They pointed out that coal fires can be broadly grouped into two categories that they're experiencing: underground fires and subsurface fires, the latter being the most dangerous. The colliery reports confirmed that upsurge in subsurface fires was noted from beginning around 2007 and seems to be moving at 2 meters per year. So this fire starts small, maybe single zigzag line or something, but it continues to burn areas beyond. And 2 meters per year is not a small thing. Just give it 4 or 5 years, we're looking at 10 meters of underground fire. And the thing is, a wildlife, people, can walk on top of those affected areas unknowingly. And in the past, burns have occurred. but factors that are affecting people to be affected. Actually, the fires were reported to have resulted in the diversion of the road linking number 2 and number 3 plants, and the diversion of a power line, in addition to injuries and a fatality that was recorded some time back. But the moderating factors that appear to increase the exposure of the community to coal seam fires include attempts to illegally recover coal and coke in those particular areas. Then, because the fire is underground, people who do not know that there is a void that has already been created underground. Then those fatalities then occur, and people will also be looking for scrap metal in some of the areas that are no longer being mined, unknowingly that there are underground fires. So, but Hwange indicates that in managing the risk, the company has installed warning signage at strategic locations in concessions, and has moved to increase awareness, education and publicity to members of the public, and also to use modern methods of mapping and so on. So we thought, Chair, these are some of the issues that you are going to meet as the committee goes to Hwange, and we thought it is not proper for you to begin to hear these things there, and then we say, we were aware. So we are doing something about it, but that again, it's a complex issue to monitor. It also requires expensive equipment for underground scanners and so on. So it is quite also very, very complex. A regulatory response and industry progress, I think we have already talked about this, where installed continuous real-time air quality monitoring at Lusambani for long-term surveillance. ZPC have refurbished 7 and 8. You will see the difference in terms of emissions. So I think all that we have talked about. We have put a slide. No, we were just anticipating to say what would be the questions that may come from the committee. The question to say, is the whole of Deka River polluted? I think we've already answered that to say no. 5 years of monitoring plus June 2026 survey confirmed a defined impact rate of roughly 10 kilometers. Why has this not been fixed after 30 years, particularly the acid mine drainage? Because acid mine drainage is a historical liability from workings closed in 1960s, predating today's licensing regime. It requires sustainable engineering, treatment, capital financing, not enforcement powers alone, which have resolved every other source in the catchment. We believe something different must be done on this particular one. If we talk about legacy liability in mining, I think this is a classical case for Zimbabwe. When we say, mines, when they eventually close, there's going to be an environmental liability and so on. In terms when you are speaking about it, people will take it as if it's abstract. But I think what you are going to see in Hwange is a classical case that as a nation, we possibly need to come up with a strategy to say, how do we deal with the post-mining environmental residuals? We can, in other countries, they put environmental bonds as the mine is operating. It contributes to the environment fund. And I'm thinking that maybe instead of worrying about Hwange doing something, this is where the environment fund was going to be involved to make sure that we deal with this kind of a problem. What exactly is EMA asking Parliament for? I think the Director General outlined issues that we also came here expecting that the Portfolio Committee to assist us going forward. So in terms of the recommendation, as a last slide, I think the Director General outlined that. Chairperson, I want to thank you and the members for allowing this presentation and listening to us EMA presenting. I submit through you.
Thank you very much.